So good morning. Actually, this Monday we have the midterm exam. So we will continue from that Wednesday. That Wednesday we already have some actual details of the transfer layer. And now we will start chapter 4. Chapter 4 talking about network layer. For network layer, we will have two chapters to discuss. Chapter 4, we have the data plane. And chapter 5, we will have the control plane. Well, so this chapter, in fact, we want to ask you to check the principles behind the network layer. And we will start from service protocols and the router architectures. So we will have some discussion for these first in today's class. Of course, we will have service models again, like the transport layer. And for network layer, we will have two functions. One is called forwarding, and next one it is called routing. And of course, for the current discussion, we will have the architecture of a router. And after that one, we will have the generalized forwarding. And we will have, for example, SDN. Well, how to have the instantiation? This one, instantiation. We want to then have the example and show you how it works. Alright, so to have the instantiation, we will have the IP protocol, and of course, if we have the network layer, we may have the NAT, you can see. And after that one, in fact, we have some middle buses after IP protocol and NAT. Well, first of all, let's have the overview. We already know we have chapter 4 to discuss control plane for the network layer, and chapter 5 talking about the control plane. As for data plane or control plane, later we will already have the meaning, what's the data plane and what's the control plane. And of course, we will have the inside of a router. So we have what's inside a router, and we already have IP. And of course, you can check the other items for IP. And we will have the generalized forwarding using SDN. And of course, we have IP, we have NAT. In fact, we will have the others, and the others we call the middle buses in the chapter. Well, so let us check service and protocol provided by the network layer. Of course, we know service provides to the transfer layer. So here we have the transfer segment. Transfer segment need to be passed through the network layer. Alright, so of course network layer will provide service to the transfer layer. And the network layer then pass it to the data link layer and go through the network. And go through the network. So direct the segment directly to the host, yes, but will go through the possible network elements. So we will have the other possible network elements. Well, so the other possible network element, here we have a host. And between two hosts, in fact, we have the other element we call routers. And should we have a switch? No. This one is the data link layer, so second layer. So actually we don't talk about the switch here. That's why we just have the routers. And for router, we need to check or to examine header. And with the header, then we know how to path it to the, for example, the next port. And so that we can move datagram. Here we call datagram. In fact, datagram currently is equal to packet. So we can move datagram from one input port to one of the output port, and so that we can forward it to the next port, and next port then be passed it to the other element, for example, router, or to the host. Well, so network layer actually provides service like this for the transport layer. And to move the datagram or packet to the output port, what to do? First of all, we can have forwarding. Well, I don't know, we can have datagram, or right now we use packet. So datagram or packet, that's okay. We can use it to denote a packet for the network layer. Well, so we'll have the forwarding. The forwarding move packet from the input of the router to the appropriate output port. And actually, this one similar to if we have the interchange. Interchange, then we need to choose the next segment of the path. So this one actually is forwarding. Also the other function, it is called routing. Well, routing actually we need to use it. For example, a routing algorithm. A routing algorithm is used to determine route from the source to the destination. And of course we use it routing algorithm. And the routing algorithm can be mapped to the trip. You can find, alright, if you want to have a trip from NTST to some university in Kaohsiung, and then you will plan the route for you if you want to go there. For example, you want to take a HSR rail. So how to be there? Then you will go to Taipei main station, then try to go to the Kaohsiung main station of HSR, and then try to find the other local route so you can reach the destination you set. Well, so of course this is the analogy if you want to have a trip. So we have forwarding and we have routing. And actually routing rely on forwarding, and so that we can have the routing. Well, we don't know, we have two planes. First one is data plane, and the second one is control plane. The data plane focus on the local one per router function. That says if you focus on a router, then what's the function inside the router? Then that one is controlled by the data plane. If so, the function should be, we need to determine how data plane or packet are running on router input port to be forwarded to the output port. Therefore, data plane here care about forwarding function. So control plane is the network-wide logic. So network-wide logic, this one is related to the routing function. Alright, so you can check this one to determine how data plane is routed among routers so that we can choose a path, and along the path then we can allow the packet to reach the destination of the receiver. Well, get back to the forwarding. How to have a forwarding? We need to check header. With the header for reference, then we can determine which output port to forward. For example, here, maybe we can check the current header, and so that we know, yes, we need to forward it to output port number 2. Well, so we have a data plane and we have a control plane. Currently in the current chapter 4, we discuss data plane first. And later in chapter 5, we discuss control plane. And for control plane, actually we can have the traditional routing algorithm. This one is included in the control plane. Talking about the traditional routing algorithms. And in fact, for routing, we can have the implementation by software-defined networking, that says SDN. And so if we have the discussion of SDN, we talk about the control plane. That says currently we don't have the detailed discussion for routing algorithm. The traditional routing algorithm and SDN, we just talked about the forwarding. Well, so per router, then we can have something like this. We just have the control plane. So let us look at this. We need to have the forwarding table. So this forwarding table actually is the data plane. Therefore, we have this one. Data plane, we have the forwarding table. Alright. So we have the local forwarding table in the router. If we care about the setting of the forwarding table and the function of the forwarding table, it's the issue of the data plane. As for the routing, based on the router base. So here we call per router control plane. So it's the traditional routing algorithm. Therefore, we have the individual routing algorithm. For example, the traditional routing algorithm, then we can have the implementation for routing issue. And this kind of routing issue is the control plane, and control plane using the per router control plane. Alright, so currently we talk about the routing, then we have a routing algorithm here. And routing algorithm here can directly have the determination which path you want to use it to send the packet from the source to the destination. And of course, we can have SDN, but before we go to SDN, look at this. Alright, so this one we call it's the per router control plane. That says it's the traditional routing algorithm. We have these. We based on. Alright, so we have the implementation along with the forwarding table and allow the router to collaborate so that we can fulfill the function of the routing algorithm. So this is the current per router control plane. That says the traditional routing algorithm. And next one is SDN. So we have SDN control plane. Well, so I already have the checking for the previous traditional routing algorithm for a few seconds. And right now, how it differs from the per router control plane. So we have the remote controller. So here we have the remote controller. And the remote controller, something like we will keep the forwarding table for the individual routers. And we have the routers. For the routers, actually, you should have its forwarding table, the local one. So for the remote side, we can have something like we can have the copy of the forwarding table for each router, and so that we can have the remote way to have the control. And this control we call the ICN control plane. As for this one, actually, yes, we will have the control for each router. We will have the routing algorithm, and of course, we will have the forwarding table. Therefore, this is the ICN implementation for the control plane. Therefore, we have the remote controllers. Well, so up now we have the forwarding function, we have the routing function. For the routing function, actually it's a function included in the control plane. To implement the control plane, we have two approaches: the traditional routing algorithm, the ICN control plane. Alright, so this is the current overview for the network layer. And the network layer includes the two planes: data plane and control plane. Data plane to be discussed in the current chapter, chapter 4, and the control plane will be discussed in chapter 5. Well, so this is the current discussion, and allow you to have 1 minute to think about any questions. Alright, so feel free to discuss with your neighbors, and also let me pass the standing page to each group. Sure, check it with your neighbors. If any question, you can let me know. Alright, so let's move on to this one. Service model. Well, similar to the transfer layer, we need to have the service model. And the current service model, what's the possible model? Let us check it. Yes, similar to the service requested by the transfer layer, we need to check, can we guarantee the delivery in time? Can we have the other guarantee? So for example, guarantee delivery, that says the reliability. And guarantee delivery within the limited time. So it's timing. And of course, to have the in-order delivery, that's possible. And the minimum bandwidth requirement is possible. And the other possible requirement, if so, then we can have the service model. Well, so for the current discussion, service model, if we talk about the internet, and for the internet, we have IP. IP currently provide the best ever service. So, can we have the bandwidth guarantee? No. Can we have the maybe guarantee for the minimum loss? No. And the order? No. Timing? No. So for the current discussion, if we choose IP, yes, no. No specific service guarantee. And it's a possible option. And it's the usual option. And why we want to have IP simply? Actually, we allow the app layer to design the possible service for those apps. And so that we have a really simple IP protocol. IP protocol, even they cannot have some detailed service model. At least IP can have the other necessary function. For example, packet or data when exchange. That's okay. So this is the service model provided by the IP layer. Well, so we have the simple description. No guarantees on delivery, timing, order of the delivery, and bandwidth availability or not. So we don't have the guarantee for the IP layer. However, if we talk about network layer, only TCP IP, actually no. If we extend from TCP IP, and TCP IP actually here we talk about IP. If we have the other possible network layer, in fact we can have ATM. ATM is the asynchronous transfer mode. If we have this kind of network architecture, then we can have a constant bit rate CBR, we have available bit rate ABR, and we have BBR and UBR for the other two possible service model. But we just check CBR, in fact we expect to have the constant bandwidth, so we have the constant rate, and the ABR available, so we guarantee the minimum bandwidth. As for the others, you can check this one. So that says, it doesn't mean we just have the IP. In fact, for the networking, we can have the other type of network. So we can have ATM. If we have ATM, then we can have the appropriate service model. And get back to the internet. In fact, internet, because IP is really simple, no guarantee, and for internet actually we can have the standard. For example, RFC 1633, we have integrated service, INTSERV, integrated service. Integrated service, then we can have a bandwidth guarantee, we can have the minimal loss or maybe no loss. And we can have the in-order delivery. And as for timing, yes. Well, so for internet in the advanced standard, we can have the service guarantee. For integrated service, all 4 items here, we can have the guarantee. And for this actually something like similar to the IP layer, but at least we can have the maybe a bit possible guarantee, so possible, possibly, and no. So this one, you think maybe similar to the IP? Yeah, similar to IP, but a bit more. So we still have the differential service, so this So this included in the IC-24 and 75. You can check that one. So we can have the service model provided by this Well, so we can have the service model, but currently we just focus on IP. As for the others, if you want to check more, you can check them in the future. So you see, we base on best effort of IP, and for IP, we have the really simple mechanism. We can have the data grant or packet exchange, that's okay. And it is widely deployed or adopted. Why? Because it's easy. It's easy then for the app layer, you can have some further function if possible. Or maybe not the app layer. We can rely on the transfer layer to have, for example, the in-order delivery, to have the other. So it doesn't matter. We can allow IP to work with the TCP. Unless you don't want to do so, you want to choose UDP. And why you want to choose UDP? For example, you want to use UDP for the video delivery. If so, then you will use UDP, and so that you will ask app layer to have the function for some guarantee, and so they have the advanced service model. Alright, you can have the others, you can check them. So of course we have the elastic. We use the term elast service. And so if we have a best this service model, everything is okay, should be okay. And if you want to have the advanced service, you should ask, for example, TCP or the app layer to have those functions. Well, so yes, even IP is simple, still rely on the function of IP. And before we proceed, we ask you to have the attendance check-in here. And let me try this again. Oh, okay, no, it won't be necessary, so let me try this directly. For students in the classroom, let me make sure. Not finished, raise your hands. No, right? And we still have 1 minute, maybe allow students online to finish the registration for the attendance check-in. But let me mention, for the midterm exam, I think you received an email from our TA, right? And if any question, you can send your email back to TA and to check something else if they want to have some further check-in. And actually, maybe that's nice. TA, let me have what's the possible way to show you the statistics of the midterm exam. I asked him to have the final version because maybe 3 of you with the score beyond 100. So finally, you just have 100 for the midterm exam. I wrote it on the midterm exam, right? So we'll have the minor multiplication, and suddenly we'll have the statistic. Also, the statistic, the lowest one should be, as I remember, because I go through quickly for the possible score. It is out of 5, so I go through it that quickly. Similar to yours, I have the directory. Check the graded midterm in the directory. So finally, okay, finally I remember. Yes, I have a file. So the lowest one should be 47. All right, except 47 almost beyond. Should be beyond 57. 57, then you think, okay, almost 60. So except one, the others almost beyond 60. And for those beyond 100, you just have 100 because we have 100 points for the midterm exam, and then we will multiply the percentage associated with the midterm exam. So the midterm exam, I think I already have the solution. You can check the solution. And most of the example coming from the quiz or maybe our activities, I think almost no problem. Except one, maybe two. One talking about if we have it should be the slow start. If we have F back, then we increase window by 2 rather than by 1, and so that we change the base from 2 to 3. And then for the remaining calculation the same. And in fact, I checked the grading by the TA, even you don't have almost okay solution. TA doesn't have more points. Alright, so I think that's why you have a higher score for the midterm exam. And the next one, the new one you don't see there before. We have one exam talking about the virtual connection. Virtual connection actually says, alright, we still have some packet switching. And packet switching, in fact, TCP/IP is packet switching. However, we have the connection as well. It's a virtual connection. So for virtual connection, we still have the connection to establish. So we have the time for connection and also for the others. and just have the actual connection or statement period. Include that one, then that's all for the discussion. Alright, so maybe I mentioned this virtually, and hopefully you can follow my something like the current hint to check the solution. And so they will know, okay, yes, even for the two actual problems, I think finally you will understand. Alright, so I already have a really quick description about the midterm exam. And maybe you have a question. Why I don't want to discuss them directly? Because of a limited time. Alright, so similar to quiz, similar to the other possible activities, sometimes I don't have enough time. And if you still have some question, let me know, and so that I can arrange possible time slot to have some detailed discussion. Alright, so about the midterm exam, I think you can share the solution I sent it to you on our line group. And use the solution there to share anything okay for your graded midterm exam. If everything's okay, then it will be necessary for you to argue with our TA. If yeah, sure, you can respond to TA, and so they will have some possible interaction with the TA. Alright, so this is about midterm exam, but then you get back to the other discussion. Yes, we have the overview for service for the protocol. Actually, protocol here we talk about IP and the other non-internet protocol. For example, ATM. And right now we check router. And since we need to have the function of a router, how router can achieve the forwarding function at least. Alright, so we have the following high-level view of the generic routing architecture. Here we have the input ports and output ports. Well, sure, we have input port and output port included in the router, but what's the inside? Well, we have two ways to implement the inside. But currently we have the general description. We have the high-speed switching fabric. We call switching fabric. And why we emphasize high speed? Because the switching should be faster. So we have the term high-speed switching fabric. And how to have the implementation later, we will already have three approaches. And actually, to have the switching, we will allow the switching fabric to work with the routing processor, and so that you can implement the routing function. And to implement the routing function, to choose the forwarding function. Alright, so look at this again. We have a routing. Of course, we have a management, and all included in the control plane. And control plane, if we have a control plane like software-defined SDN networking, so it's the software-based operation. And so that it takes more time. So operates in milliseconds. Alright. And how about hardware implementation? If we have a forwarding and it's the data plane, because of hardware operation, so the time required is the narrow second time frame. Of course, we know implement by the software will be faster. So here we just want to let you know data plane implemented by the hardware operation. So we have the faster operation. And for the software control plane, actually we need to have more time. But it is not the current discussion. We just want to let you know, yes, for the previous discussion, control plane, data plane, about the time frame, we have a millisecond and narrow second. And right now we want to check the switching fabric. Before the switching fabric, we have the input to go to the input, we have the first component called line termination. And then line termination is the physical layer. Physical layer then go to the data link layer. So we have a link layer protocol, receive. And then go to the current one. The current one is layer 3. So we should have the function of lookup, and so that we can have forwarding. But before that one, we have the current queuing. We have the line and we have the buffer, so that we can have the function of queuing. And if we have queuing, for example, okay, line up here, and wait for me, wait for the switching fabric, and then I can forward for you. So of course, we should have the input queuing. Well, you see physical layer, link layer, and we have the switching function through the switching fabric. And of course, we have the input port queuing. As for forwarding, actually, we will have the header field, and so that based on the header field, we can have the implementation to forward to the output port. And that is have the checking. Let me check. Let me check I skip any slides or not. Okay, so maybe I will check it later. So currently, yes, we have the discussion for function of forwarding based on the field. So we have the destination-based forwarding to let it know first. That's based on the header. Alright, so here we have the range of address. If we have the range of address, then we want to know how to forward to the output link. And currently we have the range from the specific one to the other. That says if we fall within the range, then sure, we just forward it to interface 0, 1, 2, 3. The other actually is 3. And we have one question. What happens if range don't divide up so nicely? Sure, we will have the confusion. Which interface we need to forward. So we won't allow a situation like that one. We should have the division properly, and so that no overlap. Alright, no overlap. Or otherwise, okay, we may have the overlap range of addresses. Which port? Port 1, port 2? Then you think, okay, either port you can do. If so, it's not okay. So here, what happens? We may have a trial. Sorry, we may have a dilemma. Which port or which interface you need to forward? It's not okay. So of course, we should have the nice division, and so that we don't have the overlap. And actually for forwarding, in fact, we can have this one, longest prefix matching. And longest prefix matching, we can check the header. We can check the actually we can check the address and choose the longest one. And longest address. And here, longest address here. We will have changes for the remaining previously. For example, here we have addresses marked in this color. But before that one, we may have the common value. So the common value we call the prefix. And the longest common prefix match the current pattern. For example, we may have this. Okay, we can have the common one, as for the others, don't care. So we don't have the same length, so that we can pass on the prefix to have the matching. Well, if so, given the possible address using the prefix and using the longest prefix matching. Think about address 1 and address 2. Allow you to have 2 minutes to discuss with take a picture first. So for you, take a picture first because I will switch. And for students online, same, take a picture first. And later, we'll allow you to check your answer, same as the current discussion or not. So discuss it with your neighbor, or maybe you can work on for yourself. So based on the longest prefix matching, and maybe identify the common pattern. So which link you think will have the common pattern? We can have the checking. For this address, okay, it says we can have the match pattern. And so match. And current one is the longest one or not. And this you can check. If we have a 0 and then for the remaining is 1, so it won't be okay to have the other possible pattern. So this one we have an interface 0. And for the second one, yes, we have a 1, 1. And also we have a 0, 0, right? So we can have the matching for the current one, but should we have the longest one? Yes, we have the longest one. So it doesn't mean the previous match pattern. We choose it directly. We should find the longest one, and so that we have a link 1. All right. So for the previous solution, according to the checking, you can check it again. So for address 1, it should be interface 0, and address 2, it should be interface 1. All right, same as your decision, right? Specifically for address 2, we gotta fill the longest version, not the fast version. Oh, okay, the first match one, then you choose it. No, you should make sure should you have a longer enough. If longer enough prefix, if yes, then you should choose the longest prefix. All right, so let us get back to these. I go through quickly for you, and then we dismiss the class. We want to know the reason later, so that we want to know, okay, why we want to choose the longest prefix. As for how to have the implementation using the memory, TCAN, ternary content addressable memory. And using TCAN, we can have this. And so then content addressable. Alright, and provided by physical catalyst. As for some specific terms, this one. Ternary and catalyst, just for your reference. And that's all for today's discussion. Alright, so let me have the closure. So today actually we start chapter 4. Now we're there. We already have the overview. And to have the overview, of course, we already have the service model. And also we examine routing fabrics. In fact, we just check part of the routing fabric to have the function of forwarding. And that's it. So this is this content discussed in today's class. And that's all. Before you go, let me Marshall, any questions? If no, see you next week. Okay, bye-bye.